In economics, we use a lot of graphs. So throughout this semester, I'm going to be recording some little videos to help you look at the graphs. Let's start with just understanding what graphs do. Graphs show us a complicated world in a small picture. When we draw graphs, we use two perpendicular lines. They're just number lines, starting here at the origin, and that's 0. And the further we move to the right, the higher the numbers are. And the further we go up away from the origin, the higher the numbers are. So we need to just understand that these are number lines, and they're nothing special. But what we do need to know is what we're measuring along these lines. Sometimes it's prices, sometimes it's quantities. It's very important that you always label your axes. And let me show you that as we look at consumer behavior this week. Consumers live in two worlds. They live in a fantasy world where they'd like to get as much stuff as they can. For example, I'd love to have 1,000 pairs of shoes and 1,000,000 CDs, but that's not going to happen. Because unfortunately, the reality of my world is that I can't afford that. So let's see how many CDs and how many shoes I can afford. This is our reality, and we measure reality by looking at budget constraints. A budget constraint is defined as the maximum amount of two goods we can purchase given our income and prices. Now, let's put along the horizontal axis, and excuse me, I just want to change the font here. We're going to put shoes along the horizontal axis, and along the vertical axis we're going to put CDs. Okay? Now, what we also need to know when we are creating our budget constraint is how much money do we have in our pocket? That's our income. Let's say we have $100 in our pocket. We also need to know the price of the goods that we're looking at. Well, let's say the price of shoes is $25 per pair, and the price of CDs is, let's say $10 a CD. Okay? Now, in order to draw our budget constraint, what we do is we want to know the maximum number of each good by themselves that we can purchase. In this case, in order to find our maximum amount of shoes, we would take our income and we would divide by the price of shoes. In this case, 100 divided by 25 equals 4. So we can get a maximum of 4 pairs of shoes. Now we're going to show this by a little line right here on our budget constraint. Okay, you can see that? Alright, now we also want to know the maximum number of CDs we can purchase. To find that, we would take again our income, and now we're dividing by the price of CDs. In this case, 100 divided by 10, which equals 10. Right? Again, we want to draw a little line here. We can find the maximum number of CDs we can purchase. Now, in order to draw our budget constraint, what we'll do is we'll draw a line from the maximum number of CDs to the maximum number of shoes. And that gives us our first budget constraint. Well, what would happen? How would this picture change If something here, if our income or prices were to change, wouldn't that change the picture? Well, let's see. Let's say our income stays the same at 100, but now the price of shoes decreases to $20. We're going to allow the price of CDs to stay the same, because remember, we only like to change one thing at a time because otherwise it gets too confusing. What would happen to our picture? Well, since the income and prices of CDs haven't changed, we're going to stay with our intercept term here. But what happens down here with the intercept for shoes? Something's going to have to change because this 25 has changed. Well, we now have a new intercept term. It is going to be at 100 income, again divided by the price of shoes, and that's going to be 100 divided by now 20, and that gives us 5. So we have a new intercept term down here. That's going to be at 5. And so we are now going to have a new budget constraint. Again, starting at the 10 for the CDs, but now it's going out to the 5 here. So we see that our budget constraint has shifted out along the shoe axis, but nothing has happened along the CD axis. One more option. What happens if our income now goes up to 200, but the price of shoes goes back to 25, and the price of CDs stays at 10? What would happen now? Well, we can't be at any of the intercept terms we've already shown because income's changed. Let's look at the CDs. What happens now with an income, excuse my spelling, of an income of 200, price of shoes equaling, oh, we don't need this up here, the price of CDs is now 10. That would give us an intercept term of 200 divided by 10, which equals 20. So we can now see that, get rid of this, our new intercept is up here at 20. But what's going to happen to our intercept for shoes? It's going to be someplace over here. An income of 200 divided by a price of shoes of 25. That gives us 200 divided by 25, and that equals 8. So our new intercept term is going to be, it's a little hard to see because I've had to put that down kind of far, but that's going to be right here. Okay? This is here. All right? So how do we find our new budget constraint? Well, it's going to start up at 20. It's going to go over to 8, and now we have our budget constraints. So you can see what happens. Now that we've looked at our reality, let's look at our fantasy. Fantasy world is the one in which I wanted all those shoes and all those CDs, but I really can't have them. To graph our fantasy world, we use something we call indifference curves. Indifference curves are defined as various combinations of two goods that give us the same amount of total utility. So Remember, we measure total utility in terms of utils. Kind of a funny name, but it's what we call them. Now, if I were to draw an indifference curve, I would draw something that looks like this. It's a little smoother, but you get the basic idea. Any combination of goods that falls along this indifference curve is going to give me the same amount of total utility. So let's say that this indifference curve gives me 10 utils of utility. Right? I could have another indifference curve which would be a little higher. And let's see if I can draw this a little smoother. All right. We have this indifference curve here, and it represents 20 utils. As I get further and further away from the origin, I move in this direction, there are many different indifference curves that are in here. And the further I get in the northeasterly direction away from the origin, the higher the utility I receive from these indifference curves. Now, if I had the best of all possible worlds, I would like to be someplace up here, as far away from the origin as possible. But that's not reality. In order to be up here, I would need a lot of money. I just don't have it. So what we need to do to bring the fantasy world represented by our indifference curves and the reality represented by our budget constraints is I need to take these indifference curves, pick them up, and drop them on top of my budget constraints. Actually, in this case, it's easier for me just to draw the budget constraints back on the indifference curves. All right. We could have a budget constraint which is here. We would have a budget constraint which was here. And we could have a budget constraint that's here. There we go. Let me just put this in here like this. Okay, now the question is, where's our equilibrium? Where's the maximum point we could be? Well, this point here is our best point right here. Why? Because it's on the highest indifference curve we can have and yet still be on our budget. Remember, any point on this budget constraint is a maximum amount. So this was our $200. Now, why not be here? What's the problem here? Or here? They're all on our budget constraint, but they're on a lower indifference curve. I'm not getting the maximum amount of stuff, shoes and CDs, or the maximum amount of utility. That's only going to happen up here. Now, keep in mind that I always want the maximum amount of utility given my income and my budget and the prices of the goods. So we want to be at this point. This is a point of tangency, a point where these two curves just touch. Check the homework assignment for this week. See if you can, if this helps you figure that out. Take care.